Yes. Wholesome generation, yes. Okay, so earlier we saw mean, median, and mode. So, we're getting like to the midpoint of the chapter now. So next thing is standard deviation. Now, standard deviation, just like mean, has a formula. But before I even give you the formula, what do I mean by standard deviation? Does anybody, I'll write the symbol, here's the symbol here. No. Hey, come on. Does anybody know standard deviation, or if they've seen it before?
Yes.
Yeah. What does it represent though? Any idea? Not quite. Let me give you an example of why you need it, okay? So if we were to take these three numbers here, and what's the average of these three numbers? Yeah, it'd be 15 divided by 3, which is 5. God, Sadiq, come on. So what's the average of these three numbers? It's 5. Okay, now, let's take this one here. What's the average of these three numbers? It'll still be 15 over 3, which is 5, okay? And then what about these three numbers? 15 over 3 is 5. So my point I'm making here is, although mean average is a good statistic, it still doesn't give us any idea of how spread out our data is. If you were to look at the first one, the numbers are close together. The second one, the numbers are further apart. And in the last example, the numbers are quite far apart, although they all have the same average, mean average. In fact, what's the median for them is also 5. So the problem is, how do we describe what their spread is? You know what I mean by spread, like how far out they are. And that's using this thing here called standard deviation. And the formula is as follows. What you do, square root. Now first you calculate the average, and for the average I'll use this symbol, X with a little bar on top. And you should also note that some people use this symbol to mean average as well. Mean average, that is. So what you do is you calculate the average first, and then once you have the average, you take the average away from all your pieces of data. You square that number, add them all up, and divide by the total. So I'll give you an example now of how to use this formula. Which one? XI meaning you go through each number one at a time, yeah. So let me give you an example here. In the first three numbers, I'll go to the left here. In the first three numbers, what's the average? 5. So first we do 5 minus 4. What's that? 1. And then you square it, and that's 1. And then 5 minus 5? 0, and you square it, 0. And then 5 minus 6, minus 1, you square it, 1. You add them all up and divide by 3, because you have 3 numbers, and you take the square root. And the answer here, can someone type in square root 2 over 3? What's that going to be, about 0.8? What is it? 0.8. Okay, for the second one, it would be square root over 3 again, 2, which is 404 for this one here, because it's 5 minus 3, which is 2, squared, which is 4. 5 minus 5, which is 0, squared, which is 0. And 5 minus 7, which is minus 2, squared, again 4. So that would be square root 8 over 3. So can you tell me please what square root 8 over 3 is? About 1.6? 1.6. 3, about, okay. And then the last one would be square root 5 minus 0, which is 5 squared, 25 plus 0 plus 25 all over 3. So that's square root 50 over 3. What's that? 4.01 about. So notice that in each of my examples here, the numbers are getting more and more spread out. And you'll notice that the standard deviation is also getting bigger and bigger. So what exactly does it mean? I mean, what is the interpretation of the standard deviation? The average is like the middle, like a typical picture. So what exactly does standard deviation mean? Well, I'll show you now. I'll go up here. Yeah, but let me give you the particular example I had in mind. If I was to look at the first piece of data, how far away is the number 4 from the average? It's 1 away. How far away is the number 5 from the average? 0. How far away is 6 from the average? It's 1 away also. What's the average of those numbers? About 0.7 to 1 decimal place. Now, how far away is 3 from the average? 2. How far away is 5? 0. And how far away is 7? 2. And what's the average of those 3 numbers? About 1.33, isn't it? 4 over 3. How far away is 0? 5. And this one? 0. And this one here? 5. And the average of those 3 numbers? It's 10 over 3, which is 3.33, isn't it? Now, oops. It doesn't match up exactly, but it's not too far away. You'll notice that my 3 answers there I got were similar to my 3 answers I got using the standard deviation. This here I got using this formula. And I'm saying, notice how those answers there are similar to the answers at the top. How would you describe what those numbers at the top represent? How would you describe those numbers? What do they mean? If the first number is 0.7, what does that mean? Think about how I calculated. Anyone? No? Yes? No?
The chance.
No, don't use any words like probability or chance. Yeah, go on. Mean of what?
The average of the distance.
Yeah, now we're getting closer to it. It's an average, but what is it an average of? It's the average difference between the data and the average. Okay, so if we picture it like this, if you have your data lined out here, and the average we say is in the middle, and then you look at all the distances. So imagine that this is our first piece of data. You see how far away it is. Our second piece, how far away it is. And you calculate the average difference. That will roughly be the same thing as this, the standard deviation. So basically I'm saying that we can say roughly, the data is on average 0.8 away from the average. And in the second case, we can say that the data is roughly 1.6 away from the average. And then last one, the data is roughly on average 4.1 away from the average. So as the numbers get spread out more, those standard deviations get bigger. This should also remind the physics students of what you did in one of your labs. You're talking about how far away something is from somewhere else. Like with the third lab. I don't know if you have to do anything like this in chemistry or biology. By the way, just to point out, my data samples had 3 data points in them. Okay? If your sample was very, very big, like maybe 50 or 100, the difference between those numbers and the numbers at the top will be really, really, really small. But even with only 3 pieces of data, they're still pretty close, you know? 0.8, 0.7, 1.6, 1.3, 4.1, 3.33. They're not too far away. So, in the syllabus, there's 2 things you need to know for standard deviation. The first thing you need to know is how to calculate it. I'll do some more examples. And the second thing you need to know is explain what it means. And when I say that, I mean the question could say something like, calculate the standard deviation, part 1. Part 2, what does the result mean? So if I was to do this for the class, imagine we calculate everybody's height, and then we calculate the standard deviation, let's say is 20 centimeters. What does that mean? What that means is, on average, people are 20 centimeters away from the average height. So some people will be 20 more, some people will be 20 less, on average. So standard deviation tells us like a type of difference. Okay, I spent a good bit of time on explaining standard deviation. So therefore more calculations. So that's when you have 3 numbers. But you notice that this formula can take it can be difficult to calculate because of the square root. So there is another formula you can use, which is a little bit quicker. Okay, and I'll show you what it is. In the exam and in the exam and the formula book, they would prefer you to use this formula. It gives you the exact same answer. Standard deviation equals square root. This one squared minus this one here squared. So let's take my first example, 4, 5, 6. You're looking at me confused. Okay, so here are 4, 5, 6. We know what the answer is going to be. What is it going to be? 0.7, wasn't it? 0.8. So what does this mean? What this means is first you get the average and then you square it. So what's the average of these 3 numbers? What is it? 5. And then you square it. And so what do you get? 25. Whereas this here means first you square, then you get the average. So if I square these, I get 16, 25, and 36. So can somebody please add them together and divide by 3 and tell me what you get? Now again, don't do that. You know what I need you to do. Take out your calculators and type them together. 25.66. And then we take square root 25.66 minus 25. What's that? 0.
Isn't it the other way around?
25.16.
Why can't you just use your calculator right? Kids these days don't know how to do anything by themselves. Right. No talking time now. This is teacher doing it time. All right. 25.66. Yeah. Thank you. 0.8182. About 0.8. 1 decimal place, 0.8. And that is the same answer I got using the other formula, 0.8. Okay, you got that? So what's the difference in the 2 formulas? No difference. In fact, you can show that the formulas are the same. But why would I use this formula? This formula is actually a little bit easier to use when you have more than a few numbers. When I only have 3 numbers, it doesn't really matter. But when I have many numbers, this formula becomes a bit quicker to do. So we'll do another example with more numbers though. Now somebody had some question about something being the other way around. I'm sorry, you're right, I have it the wrong way in the formula. Please make note of the squares. First this one is here and the other one is like this. Okay, can I do another example? In fact, Brendan, I think you pointed it out, it doesn't actually matter because it's always going to be the bigger number minus the smaller number because you can't have a negative in the square root. And in fact, this one here will always be the bigger one and this one here will always be the smaller one.
But that's still just, that's the way the equation is.
This will be always the bigger one and should always be first. It'd be you made a mistake if this ended up being bigger.
It's not that big a deal.
Huh?
It's not that big a deal.
What do you mean, what's not that?
If the bigger one was on the left and on the right, you just get a negative value. You should know that that's wrong.
Yes, exactly. Well, you think that, wouldn't you? Yes. Yes. Yes, the number will still be correct. Yes. Okay. Can I do another example with more numbers now? So let's say we have here are our numbers 5, 6, 10, 4, 1, 2. So if I look at these numbers, just roughly in my head, the average looks like it'd be around about 5, yeah? Just roughly. Listen. The average here will look like it'll be roughly around about 5. And you can see that most numbers are between 1 and 10. So I'm expecting my standard deviation to be maybe around about 2. Because on average it's about 2 away from the centre. Now let's calculate it. So first we get the average of these numbers. So the average here would be, are you sure now?
Yes.
Okay. So the average squared is 4.6 squared, which is 21.7. Okay, now what you do next is you square them. 25, 36, 100, 16, 1 and 4 and get the average of these. 25 plus 36 plus 100 plus 16 plus 1 plus 4 divided by 1, 2, 3, 4, 5, 6.
30.3.
Okay. So that means the average of the data squared is 30.3. So then the standard deviation will be that minus 21.7 and then square root the answer. And I got 2.9. So I did this number minus this number and then took a square root. Okay. Now, let's have a look at another example. Let's do
With the circle.
it's a 0. If you look at this data, what's the mode average? It's 2. What's the median? Well, how many numbers do I have? 5, 6, 7, 13, 14, 16. So So I need to look at 8 and 9, which will also be in the 2 position. So the mode is 2, the median is 2, and I reckon if you were to calculate the mean average, you'd also get roughly about 2 as well. Now, before I calculate it, what do you think the standard deviation should roughly be as a number? What do you think? 1, 1.5. I think if the average is 2 and most numbers are between 0 and 5, I'd say maybe about 1.5. It's not that spread out. So let's calculate it. So first we need to calculate the average. So do you remember how to do that? You multiply, add, and divide by the total frequency. So that would be 0 plus 2 plus 12 plus 3 plus 0 plus 10 all over, what did I say, 18? 16 was it? Sorry. 2 plus 12, 0 plus 2 plus 12 plus 3 plus 0 plus 10 at the end. That's a 10 at the end. Thank you. Now I need to also square that.
2.84.
Squared 2.847, yeah. Well, if we rounded off that one there. Okay, what we do next is the same thing, except now we look at squaring each data piece and then getting the average. So that would be 0, 1, 4, 9, 16, 25. So there it would be over 16 again. 0 plus 2, then 4 times 6, 24 plus 9 plus 0 plus 50. When you multiply now the x squareds with the f.
Can we multiply them?
Yep.
Can we multiply them and then square them?
No, it has to be square first, then multiply. No, that's a good point. You must square first before you multiply by the frequency. 0 plus 2 plus 24 plus 9 plus 0 plus 50 divided by 16. What did you get? Good one. What's wrong?
I don't understand.
This one here?
Yes, I don't understand how.
This means you square the data and then get its average. So you see here was the original, and then here is it squared. See, these are all squares now. You get the average of that. So it's like this here replaces this. And multiply by the frequency, yeah. Okay, so now we get the result. Well, look at that, 1.57. And just so you have it here, the average, by the way, was 1.69. So the reason I'm writing that down is because sometimes they might ask you to make a small comment. So the comment would be, this data is on average 1.57 away from 1.69. Yeah, that's the regular run-of-the-mill average. So that tells you that if you were to picture this data, you're picturing the center of it being 1.69, and then your points being on average 1.57 away from it.
Sorry, how did you get 4.5?
Oh, that's just the regular average, like the x multiply the f. It was what I did here before I squared it. If you square this number, you'll get that. It's this formula here, Sarah. X multiply f all over total f.
What about Caroline to give us in the previous example?
Earlier today, you can use that formula. The one up here, this one. These two formulas give you the exact same answer. No difference. I'm just saying that in the exam, I think it's better if you use this one for two reasons. Number one, this is the one that's in the formula book. And number two, it actually is a bit quicker than using this formula.
Could you please scroll down?
Down.
Where did you get the...
Wait, hold on. Scroll down to where?
Yes. Why didn't we minus the... or subtract the...
Oh, we did. I didn't write it down. This number here.
Then what's 1.69?
Whoa, give me one moment. So this number here was the square root of 5.3125 minus 2.848. And then, whoa, oh. That number there, that's just the regular run-of-the-mill normal average. That thing or that thing, whatever symbol you want to use. Can you write down this example now? And I'm feeling there's some confusion here, or is there a mistake, or what's wrong? That is what Sarah was just asking me what I was explaining to her.
I was asking Sarah what she was asking.
This was a mistake to do. Can you call out this information to me here? So how many zeros do I have? How many? 5. 1, 2, 3, 4, 5. Okay, what's next?
1, 2 ones.
1, 1.
And then we have 6 twos.
1, 2, 3, 4, 5, 6. Next?
1, 3.
Yeah.
Then 0, 4.
Yes.
And then 2 5s.
Okay. So this is my data here. As you can see, putting it into a frequency table is much more convenient than writing it all out. Yes? Now, just to show you, Excel can calculate things like average and standard deviation. So I'll just show you here. Average (1.68), and then it can also do standard deviation, which I think is ST-dev, standard deviation. You see 1.6 as well. Okay. Yes. I just want to show you this because some people may want to use this in their maths project too.
We'd have to, wouldn't we?
I don't want to tell you too much yet, but I'm just saying, watch out for it. Yes?
Sorry, is there any UCB classes to help us with the maths project?
You know something? Nobody has ever asked me this question before, and I've been doing this 6 years. So the answer to it would be with another question. Would you like ESAP
Yes.
classes?
But I don't think Mr. Stephen needs to do that. That would be a
No.
Oh my goodness, he would be heartbroken if he hears you saying this.
A nice way to put it is that his field does not specialize in this.
You saying he's dumb?
No. He's severely ignorant about.
Right. The ESAP class, you would like it to, some time to be spent on the maths project. Shh, hang on. I'm done with the maths project now. Just so I know, would this be general opinion?
Yes.
This side of the room looks so tired. Come on.
Brendan is speaking to
Come
the
on.
people.
No, everybody now. Would you like some ESAP time for the maths project? Are you sure now? Alright. Because Stephen B will only be helping you with the writing part of it, of course. And this is fine. Right.
No. You won't tell us what numbers that no.
Because writing out is fine. I mean, it's not the big.
Wait, hang on. You want Stephen B to help you with the number part of the
No, that's
project?
the thing. We want help with the number part. Not.
Okay, let's just clarify. ESAP is only for words. So your question is not really, can we have ESAP for the project? Is, can we have a class to help us with the project? In EAP time? You're being so particular.
And
Well,
in math
typically
time.
during the period of time where we're working on the project, we've got nothing else to work with.
Do you have ESAP on Mondays?
Yes.
So try not to get it.
Morning.
But it's 1 hour one group and then 1 hour the other group, yeah?
We have one tomorrow.
But I'm not free at that time.
It should help.
What are you doing in ESAP at the moment?
Whatever you want to do.
I may take Monday class next week for it, for ESAP.
And
Both hours. 1 hour for one group and 1 hour for the other group.
apparently, this Monday, Lorraine will not be.
Yeah, but there's,
But I'm not free. I might not be free at that time. I know I'm free during that ESAP time you have on Monday because it's at 11 and 12, and I know I don't have class at 11 or 12.
Isn't that?
Yeah, that's not good.
11 to 12 for one group, and 12 to 1 for the other group.
Why don't you just let us meet one group instead of explaining twice?
But are both groups free for the double hours?
When physics people have ESCP, we're free.
They're.
Ah, okay, so it would be possible to have everybody for the 2 hours. No, but wait, hang on. It might be better to have it in, because then I can give more individual time, which I think would be better actually.
You can explain in 1 hour.
Some people in the class are loud and take up a lot of teachers' time.
Okay, so then we'll go.
Hey.
Physics. Like you'll cover.
So look, it doesn't matter. I will let you have ESAP tomorrow, don't you? Yeah. So I'll talk to Stephen, and if it can happen, I'll get him to pass the message on to you. And then what I'd like you to do, if we can do it, is on Monday you should bring your laptop with you and whatever piece of work you've done so far on it, and then I can offer you guidance then. But really, please do not come to ESAP on Monday if I am doing it with a blank Word document and look at me and go, all right? Don't do this, right? Right? Yeah. Okay. Let me give you the questions now. How many people have actually started?
That's a lie. No, come on.
Brendan.
Okay, so I guess you're going to see lots of...
I see this, yes. So there was just one example which I haven't done because I think you can do it yourself now. That's the one I had there was a frequency table. What's the other type of table? Group frequency. But the only difference is the number you use is the midpoint number. That is the same.
Could you please go back to
The notes, yeah. This, Sarah? Get working on these.
just finish my
Now you have to start. He's exhausted for 3 hours of maths.
Oh, that's right.
I speak on his behalf.
Too much maths?
Yes.
Yeah.
There's nothing for you to ask me. You could ask me.
Why did you come to this class? You could do a Avenue, or Joseph on it, an Avenue in Alberharney. Come in for a half day. Then go home. This class?
No, I want to skip the other class.
Ah, good call, good call. What is the class you're going to skip now? Yeah, you don't need it. Cool.
Or you could run away, that's what I did.
Yep, or just run away. Yep, yep.